Hey AP Stats kids. Here we're looking at your Chapter 11 review question number 3. We're going to be looking at the association and dependence chi-squared test. Hopefully, I don't know if it got covered up. Maybe it's just my copy, but there should be a ho and a ha there. But it says, do the data provide convincing evidence of an association between gender and having allergies? So here, they've only taken one sample. If we only have one sample and then they ask them two different questions, they're asking them, do they have, or like, what is their gender? And then they're asking them, do you have allergies? That's how we're knowing. If we scroll back up, you have two variables from one population, right? So here they took one sample and they asked gender and whether or not they have allergies. So that's how we're identifying that it is a chi-squared test for independence or association. All right, so here we have our ho and our ha are already given to us. The ho is that there's no association between gender and having allergies. The ha is that there is an association. Okay. In other words, our ho would be that they are independent variables, and your ha is that they are dependent variables. Here we have the random condition is met since they said that you had a random sample of 40. The independence condition was met since there are more than 400 U.S. high school students, and each individual's gender and allergy status are independent of the next. Law of large counts, they already gave us all of our expected counts in that table. That makes our life a lot easier. So if we're looking at those expected counts, they're in those little parentheses there. All right, now we're going to look at calculating the chi-squared test. So if you remember your formula, the chi-squared test statistic in this chapter should be the sum of all of your O minus E squared divided by your E's. And since there's 4 of them, they typically want you to show this all the work. So we're going to have to go through and go 10 minus 10.35 squared divided by 10.35. If you do that, you're going to get a number, of 0.0118. Then you're going to do the next observed minus expected squared divided by expected. 8 minus 7.65 squared divided by 7.65 should be 0.016. Two more of those. So O minus E squared divided by E, and O minus E squared divided by E. Okay, that next component should be 0.0097, and the last one should be 0.0131. Okay, if you go through and add those together, then you can also double check your work. If you did a chi-squared test on your calculator, you get 0.00506. So fairly small chi-squared test statistic. It says which one of those components contributed the most to the chi-squared test statistic. So if we want to know which one of those made that number the biggest, sometimes they'll ask you which one contributed the least. This one that contributed the most, you were looking for, oh no, that's not it. Go back. We're looking for which one of these numbers was the highest. The one that was the highest was this number right here. So 0.016 is more than our other values. And so since you're comparing those decimals, the 0.016 is the biggest, and that came from the 8 minus the 7.6. So that's going to be our males with allergies. Okay, so they're contributing the most to that chi-squared test statistic with that value of 0.016. That was the highest. Which one of the calculations represents the component of the chi-squared for the males with allergies? It's kind of being like, okay, we'll go back. What was the calculation? And that's the link that we already made. Like, who was that? That was the 8 minus the 7.65 squared all over the 7.65. Those were those calculations. To find the p-value for this, remember our chi-squared test statistic is skewed right. We're always doing a right-tailed test. If our number, technically, we're going to be really, really close to 0. So this p-value is going to be pretty large. So the probability that chi-squared would be greater than 0.0506, chi-squared CDF, lower bound is the test statistic. Right-tailed test means that you're always going up to infinity. And then we need our degrees of freedom. So the degrees of freedom for the two-way table ones are row minus 1 times columns minus 1. And since it was a 2 by 2, this is going to be 1 times 1. So our degrees of freedom are just 1 on here. If you go through and calculate that out, I got 0.8220 as that p-value. So very large p-value. They didn't necessarily ask you to go through and conclude, but if we had to go through and conclude, that p-value is very large. So since p-value is greater than alpha at any one of our little percentages, even 10%, we would go back and say there is an association between gender. Oh, sorry. Other way around. P was not low. We're failing to reject O. There is no association. We don't have enough evidence that there is an association between gender and having allergies. So, like, since our p-value was 0.822, which is greater than our alpha at even 10%, or you could say 5%, we fail to reject Ho. Okay, we do not have enough evidence that there is an association between gender and allergies. I don't know if oh gosh. There's an R in there. Yeah, got it. All right. The next ones, you're not really doing anything except for naming the chi-squared test that would be used. So we have the 3 different types. We have a chi-squared goodness of fit test. We have a chi-squared homogeneity of proportions test. And we have a chi-squared test for independence or association. And we really just use those interchangeably depending on which problem it is, because they'll say kind of one of those words. They'll either say dependent or association in the problem. This first one, an article about the California lottery, okay, is trying to figure out it, like, does the breakdowns match what was reported? Does that match? So when they're asking about does it match, this should be a chi-squared goodness of fit test. Okay, the next one's got two-way tables, so right away we can kind of say, is it going to be the association test or homogeneity of proportions? Keywords that you're looking for here. It says independent samples were selected from each of our 4 populations. So when we have different populations and we're trying to see, like, is this one variable, right? You only have the one variable. How much did they smoke each day? So we have multiple populations. we're only asking or collecting one variable. This is our homogeneity of proportions test. Okay. On the next one, they said that keyword, whether time spent watching television is associated with cardiovascular fitness. So right away, that should be like a chi-squared test for association. So are these things associated? You only have basically one population and you're recording like two different variables from them. First, you're asking them how much TV do they watch, right? That's your first variable. And then you're also measuring how much or how physically fit they are. That was your second variable. So because you have two different variables and you're asking one group, that's your chi-squared test for association. All right, this last one, an accounting firm in Mississippi has clients in different states. The accountant thought that the distribution from one year to the next had changed. So they took a sample and then they classified them according to residence. So we have one population or one sample, and we only have where did they live, the state of residence is that one variable. And we're checking to see, like, did it match again? Okay, so hopefully you said chi-squared goodness of fit test for that one. All right, hopefully that helps you with your review. Try your take-home quiz on chapter 11, and we'll see if you can't turn that in by taking pictures and sending them to me through Google Classroom by next Wednesday. All right, have a great weekend, guys. Miss you.